what we're going to discuss today is about storing data. It's a part one, because today I'll just go through the basics. And maybe next week we can talk about actually a concrete application. Okay, but I don't think it's so hard to create these applications. You'll probably see it later on. Okay, so today we're going to cover just one new library called Smojo/chat/database. Okay. All right, and it's all about, of course, databasing and storing data. So there are existing data storage solutions. Obviously, you know about MEMS. You probably have done or used the persistent cache, and you may or may not have done the group data. Okay, so let me just outline briefly what these things do. So the MEMS exists only on the session. So a session is a back and forth. When the user clicks on your chatbot, he goes back and forth, with the interactions. It's called a session. When he closes your chatbot, the session ends. Okay, so the MEM only exists on the session itself. And the purpose of the MEM is not really to store data. It's really to create the illusion that a session is a continuous thing. Okay, what's really happening when in your chatbots is that each time the user clicks on something, or let's say he types in something, that data actually goes to the server. The server wakes up the chatbot. The chatbot then examines the MEMS, which are stored actually on your chatbot itself on the user side, and then it actually does everything, right? So the chatbot itself is only alive, so to speak, occasionally when the user sends something back to the server, when he clicks on the send button. Otherwise, the chatbot is quiet. It's actually dead. Right, so it runs for a while, then it exits, runs for a while and exits on the server side. But the MEMS allow you to create the illusion that the chatbot is always up, always trying to respond, and can remember what it's done before. So it's not really a data storage solution, it's just a way for you to store data for the session only. Okay, so the persistent cache was a simple mechanism we put in place immediately almost after the MEMS to actually solve the problem of storing data across sessions. So oftentimes that you want to store something like, whether the user logged in or not, or maybe his preferences and so on. So the persistent cache is meant to be something that is for the user, but it will exist or across sessions. So even if the user switches off the chatbot, the data is still there. And when he calls up the chatbot again, that data can be pulled from that persistent cache and used in the data storage. Okay, and so of course the data does exist across the sessions, but the data is confined to a single device. In other words, there is actually a cookie that is stored on the user's side, which identifies the user uniquely, and that data is stored and only accessible by that user. All right, so even your chatbot cannot access that user's data. It is completely personal. Okay. Now, there's also group data, which was brought in really to solve a very specific problem. We were running some competitions in Indonesia, very large competitions. In fact, they're still ongoing, and where they've gone into phase 3 now, where they're actually being used in schools and so on. The idea was, can we use chatbots to actually help schools in Indonesia improve their lessons? And so I think sometime around September, October last year, we ran a very large competition where we had thousands of people actually join this, and several hundreds of teachers actually also joined the competition as well. So the idea was that group data was designed for teachers to capture quiz data from their classrooms. Okay, it's got very little use apart from this apart from this scenario. So the data, again, the data here exists across sessions. You can use this data to store data from multiple users, but the data is stored on per chatbot. Okay, so for each chatbot, the data is stored per chatbot, and there is also limits on the number of users, chatbot users, that can actually store and retrieve data. There is also things like how much data you can store and so on, right? And also access restrictions as well, because we don't want we didn't want actually people from the outside to access the test scores of students. All right, so there's a lot of restrictions on what you could do with this. All right. Plus, I did mention the setup for this group data is actually pretty complex. And there is actually a whole tutorial designed to actually show you how to do this, and this is CU 102. Okay. So today, on the other hand, we are going to examine a brand new approach for data storage, and that's in the cloud word called Smojo/chat/database or dbase. And similar to what is it called? Persistent cache and persistent storage and also group data. The data also exists across sessions. The data can be captured across multiple users and chatbots, but from the same creator. So in other words, the big constraint is that if let's say I've got a user ID, let's say it's Arnold or something else, then I can create or can capture data for anything created by Arnold. Okay, but I can't access or capture data created, let's say, by Vincent or by William. Okay, so it's on a per creator basis. The data is stored on a per creator basis, but many other people can store their data to this data store. Okay, and data can also be shared between chatbots from the same creator. So again, the constraint is that it's from the same creator, and that means that you can create dashboard type bots where you can collect data from one bot and then store it. You can process it in a different dashboard and so on, right? Which allows you to simplify your chatbots and build them piecemeal, right? Rather than having one massive motherboard to do everything. Okay, so this is very useful for workflows and quite a few other things that we will talk about perhaps next week with a live example. The setup is very easy. You will see it shortly, and the usage also is fairly simple, straightforward. And there are no artificial limits like there were for the group data, which is like classroom data. Okay, so this is the big advantage we have here with the chat database. But of course, you still need to bear. There are some engineering constraints, which I'll talk about now. Okay, so just to briefly recap, it's this Smojo chat database is used to store and retrieve data. You can retrieve it across multiple users and chatbots from the same creator. Okay, you can have even multiple virtual databases. Actually, all the data is stored on one file, right? But you can pretend there were multiple databases. It's very early release, and we will definitely be improving upon it, but we will always keep in mind backward compatibility. In other words, although there might be, let's say, speed ups in the data access and so on, or let's say improvements, you shouldn't see that affecting you in any way. Okay, if it did, then we might release new words for you to use rather than change the existing or meaning of the existing words. All right, so your existing bots shouldn't break. Okay, so let's just step back a bit and ask ourselves, what is a database? So a database is really a way for a bunch of data writers or data creators to store data in a single location, or maybe sometimes multiple locations, and for that data to be read by multiple readers. Okay, so the idea is that the writers could at different times or even simultaneously create data and store it in that database, and the readers can actually retrieve data at any time. Okay, and if you think about it, when writers are writing and readers are reading simultaneously, then of course there could be problems, right? So there are actually guarantees that existing databases have, right, which guarantee things like consistency, atomicity, and so on, which we'll come to later on. Okay, but this is the general picture of a database: many different writers and many different readers, all doing stuff at the same time. Okay, and the engineering behind to actually make this work is actually very complex. Okay, so a database is simply a storage mechanism for data, and the devil's in the details, right? Multiple people can write to the database, right? Same for the reads as well. And the difficult part comes in when the database has to provide guarantees for data storage. Okay, so a famous guarantee is called ACID, ACID: atomicity, consistency, independence, and durability. Okay, you don't have to know what that means, but what it actually means from a user's perspective is that all of this stuff can happen without anything breaking. All right, everything is consistent. Right, you won't get a situation where your account, for example, in one place is let's say increased and another place is decreased. Everything is consistent. Okay, the Smojo chat database, for it to be simplified, because the engineering, we don't want to go into the heavy lifting of the engineering and so on, is simplified because our scenarios are also simplified as well. So we make a certain two big, how do I say, simplifications to this scenario. Okay, the typical database scenario. The first simplification is that the writers are serialized. In other words, let's say instead of everyone writing at the same time, you can still do that, but they are put into a queue. Okay, so that's called serialization, right? So they are queued to write into the database. Okay, that's the first simplification. But on the outgoing side, you can have multiple readers, right? Reading at any time. Okay, there's no restriction on the readers, only on the writers. All right, and that this approach really simplifies how we code and everything else. We can make the code much simpler and faster. And the second thing is that instead of an arbitrary database, we focus really on what's known as key value type databases. Okay, so in other words, you have a key and a value. So it's a lot like your hash, or a lot like your persistent storage that you're more familiar with. Okay. All right, so those are the two things that will be simplified in order to get the engineering manageable and done, within a reasonable time frame. Okay, but these two things have implications. The first one is that because it's serialized on the writes are usually much slower than the reads, usually about 10 times more slower. And the reads can very rarely, okay, fail. We tried our best to make it not fail, but I wouldn't say it's a guarantee that it won't fail during a write. So for example, let's say one of the items is being changed, and for a brief, perhaps within a nanosecond when it's being flipped, then if the person makes that read, then it may fail. Okay, but of course it's unlikely. Now, the benefit, of course, is that with these two assumptions, or simplified, we have a simplified design, and therefore it's more robust. We can actually make it so that it recovers from failure very easily. And we also made it so that it can scale up. So in the future, if we have many other users on the system, we can scale it up quite easily without too much trouble. Okay, but the other implication is that a few large reads or writes are often better than multiple small reads and small writes. So in other words, it's better for you to write a larger but fewer, rather than very small things that you write, but more of them. Okay, because it's simply slower. Okay, so where can this be used? So again, we've got wherever you have got few writers or many slow writers, so that's where you can use, where this is a good fit, right? Of course, you can have multiple simultaneous readers, so that's fine. And of course, you also want to have few large reads or writes. It's much better than smaller and many smaller reads and writes. And therefore, it's also better to write more complex data structures like hashes or sequences or tuples even, okay? And that's a better fit for, in fact, a lot of the reasons why you want to use this database. Okay, so where can it be used? Well, in situations where you want to write once or periodically. For example, let's say you already have an Excel sheet of data and you want to dump that, let's say once a day, or let's say once an hour, for example, right? Now that's a good scenario, okay? And if you're talking about like 1,000 rows and so on, yeah, that's reasonable for you to do that, okay? The other use case is in workflow type applications, where there might be many different bots and you want to collect data from different parts, right? And then data flows through maybe either a linear pipeline or very complicated pipeline. And usually typically the number of people involved is 1,000. I would say honestly about a couple of thousand is fine for one usage. All right. So this is also another use case. Of course, these numbers can be scaled up if we use something that's more dedicated. This is a shared system, and that's why these numbers are more realistic. Right? Where it's not useful is in multiple to multiple real-time communication. In other words, let's say you're trying to build a chat type application, okay, where you want very fast real-time chat, then this is not a good use case for this system. All right, for that, you want to use something that we're going to introduce later on, which is a WebSockets, okay, which is different from databasing. Okay, so I hope that gives you a bit of a quick overview on what we're doing. There are only 3 words for this thing in this system. There's the usual write, which is the db hash exclamation mark. That's db write. It takes a value, a key and a value, like your hash or your persistent storage, but additionally it takes in a database name. Okay. And this allows you to actually write for different databases if you want to. All right, it allows you to have a test database and a live one. You can run the test, and you can delete the test stuff, and you can write on the live one, etc. Right? Similar for the reads as well. It's the key, the database name, and then that will return a value. And db drop, which deletes a key value pair. So you indicate the key that you want to drop or to remove from that database, and it will then remove it for you. Okay, so just 3 words, nothing else. It's very simple. Okay, so there are some things that you need to pay attention to. There are actually 2 versions of Smojo Chat Database. There's the basic one, which is for chatbots, which you should use for on your chatbots itself when you publish. But when you test it in the or use the system in the IDE, in the AutoCAD IDE, you can't use Smojo/chat/database. We will try and consolidate these 2 later on. You need to use instead /database/test. Okay, so the /test is important. Okay. Again, I just want to emphasize that data is stored on a per user basis, not on a per chatbot basis, and not on a per chatbot user basis. It's on a per user basis. So if, let's say, on your user account, in other words. Okay. And there is a data storage allowance. I've tentatively set it to about 6 megabytes per user, which honestly should be more than enough as long as you're not storing things like images and so on. Or if you are storing images, then you want to consider removing them or updating them or deleting them, all right, on a regular basis. Okay, this is not meant for large scale image storage. It's really meant for data. Right? You can store images if they are few, and if you remove them once they are not required. Okay, so all data is available to all chatbots belong to the user. In other words, anything that belongs to your account, whether it's the IDE or anything you create, can have access to this data set. Okay, documentation as usual is in Smojo/doc, just called docs Smojo/chat/database or /test. The test one is identical to /database. It's just the initializations that are important. Okay, so now this is just part 1. Next week we'll have part 2, and the idea is that I will actually help you to build something from scratch using this the system. What I'll do today is to demo the whole thing on a very rough basis, so you can see how it works. Okay, and for a complete application, I suggest why don't you give us some suggestions on what you want done, and put it on Discord, perhaps. Okay, or maybe we'll just set up a form or something where you can just put in your suggestions. Okay, and then we will build. Maybe I will then go through one of your suggestions next week. Okay, so let me just demo this for now. Any questions, guys, so far?
No. All good.
No.
Yes, William.
So let's say if we have, over time, we have many databases, how do we recognize the old, how can we remember the list of databases that we have?
You have to document that. So the onus on documenting your databases is really on you. Okay, I'll show you a
command to list out the databases for that user.
It's possible. It's possible, but I would next week, I'll show you some practical ways in which you can do that. Okay. It's not as hard as it looks.
Yeah.
Okay. Okay. So let me just give you a simple any other questions? Nope. Okay. So let me. Okay. So unlike the previous systems where you need the chatbots and so on, you can actually do this without a chatbot. So it's just, so let's do the doc first. Smojo.AI. Okay, so you can see the just 3 words: the store, or the write, the read, and the drop. For now, I will put in more words perhaps later on, or we will put in more words later on. If that's not enough, I think I can think of a couple of where you can talk about the size of the database or records, or let's say trying to drop a whole database instead, right? So we're still deciding on that. Just be patient with that, okay? And the test one is the same as, it's identical. Oops. Yeah, but it is identical. Okay, I'll probably consolidate this into the database. Okay, so we'll consolidate this into this thing so it's automatic and you wouldn't have to fuss around with /test. But for now, you have to use /test if you're using this IDE and running things within the IDE. Okay, once it runs within your chatbot, then you don't use test anymore. So let me just call up the test, and let's say I want to store a simple thing. Let's say hello. This is my key, and the value could be something like, I don't know. Okay, let's get a simple value. Say 1, 2, 3, 4. Okay, that's pretty trivial. Let's call it my dbase, db. Okay, my db. All right, and all you got to call is just db exclamation mark like that, and run this. Okay, it should say okay. Right. So what happens is that this is the key, this is the value. Now I said this is a very small value, so you shouldn't be doing this. Your values should be much larger, in the sense that it should be a hash or something else more complicated, or maybe even like a sequence. Let's say a sequence like, I don't know, of things, right? So let's say it's let's say animals. Okay, so let's say it's dog, cat, a giraffe, a bird. Okay, and I'm going to bind this to my animals. All right, and then I'm going to just store. So let me just recall this first and see if does it work or not. All right, so I'm going to recall it. Okay, and it should say 1, 2, 3 like that. Okay, but like I said, don't store small data like this because it is just awful. And I'll call it animals and say okay. Now if you run this, this is where the thing hasn't saved the thing yet, and you're actually asking it to do the next part, right? So let's just store this first. Okay, and then we will go up there. Yep, and it's giving you the list. Okay, so typically this list here, or a hash map and so on, would contain a lot of your intermediate data, which you then change. So what you shouldn't be doing is having as the key animal 1, animal 2, animal 3. Then you got lots of different. You're sorting a lot of small data sets, which is bad. Okay, it's slow and it's not suitable for how this thing is designed. You have to store a little more data for this stuff. Okay, there are exceptions, of course, but that's why I think it's important to go beyond something like this, and to actually toy examples like this, actually to try a real application so you can see this in action. Okay, but let's try the last one, which is hello my DB. All right, And then we'll run this first. And then once you've done that, okay, it says now. That means you can't find anything for it.